Long before the world understood the hidden architecture of nature, there was a young Scottish thinker who saw patterns where others saw chaos. James Clerk Maxwell lived in a time when electricity was little more than a scientific curiosity and magnetism was treated as a peculiar trick of nature. People could make sparks jump, they could watch compasses spin, they could feel the strange pull of magnets, but no one truly understood what connected these phenomena. The forces were invisible, mysterious, and unpredictable. They behaved like separate worlds with no bridge between them. Yet Maxwell sensed something deeper beneath the surface, something waiting to be uncovered by a mind capable of seeing beyond the limits of the visible world. From childhood, Maxwell had an unusual gift. He could visualize ideas in his mind with extraordinary clarity. While other children played with toys, he studied geometric shapes, reflections of light, and the movement of objects. He found patterns in everything, patterns in motion, patterns in light, patterns in nature. And as he grew older, he carried this gift into the realm of physics, where he became fascinated by two forces that shaped the world, but refused to reveal their true nature. Electricity and magnetism were like unconnected islands. Scientists knew that rubbing certain materials produced static sparks. They knew that electric currents could create heat and motion. They knew that magnets could pull or push objects, and that they always pointed toward the Earth's poles. But what they did not know was that these forces were part of a much larger story. Maxwell was determined to find that story, to uncover a unity that no one else had imagined. He began by studying the experiments of scientists before him, Faraday, Ampere, Coulomb, men who had observed remarkable effects, but had struggled to form a complete theory from them. Faraday discovered that changing magnetic fields could produce electric currents. Ampere rediscovered that electric currents could create magnetic forces. Coulomb measured the strength of electric charges. Each discovery was like a piece of a puzzle, scattered across time, waiting for someone to understand how they fit together. Maxwell became the person capable of solving that puzzle. But he didn't do it through simple observation alone. He did it through imagination guided by mathematics. He believed that mathematics could reveal truths about the universe that the naked eye could not see. And so, he built a new kind of vision, one that allowed him to see invisible forces moving and interacting across space. To understand his approach, imagine trying to map the wind. You cannot see the wind directly, but you can see the leaves it blows, the waves it forms, the branches it moves. Maxwell looked at electricity and magnetism the same way. He watched their effects and used them to imagine the unseen flow of forces behind them. Where others saw isolated events, he saw connections, patterns, and relationships. He realized that electricity could create magnetism, and magnetism could create electricity. This was not coincidence. It was a sign of something deeper. The two forces were intertwined, locked together in a relationship no one had fully explored. Maxwell began forming equations to describe how these forces behaved. These equations were more than mathematical expressions. They were windows into the structure of nature. They showed how electric and magnetic fields interacted, strengthened each other, weakened each other, and created dynamic structures that moved across space. For the first time, Maxwell revealed that these invisible fields were not separate entities. They were parts of a single, unified force, a force that operated through patterns rather than particles, through waves rather than isolated events. He saw nature not as a collection of disconnected phenomena, but as a harmonious web of energy, flowing through space in elegant rhythms. This was revolutionary. Before Maxwell, scientists believed forces acted only when objects touched each other or when a mechanism physically connected two points. But Maxwell showed that empty space was not empty at all. It was filled with fields, structures that could stretch, bend, vibrate, and carry energy. This idea changed science forever. It introduced a new way to think about the universe, a way that allowed the invisible to become part of scientific understanding. One of Maxwell's great insights came as he studied how electric and magnetic fields change over time. He realized that when an electric field changes, it creates a magnetic field, and when a magnetic field changes, it creates an electric field. The two forces were constantly generating each other, like dancers locked in an endless, graceful exchange. Maxwell understood that this interaction could propagate through space like a wave, and when he calculated the speed at which this wave would travel, he was stunned. The speed matched the known speed of light. This was the moment everything changed. All at once, Maxwell realized that light, something humans had known since the dawn of time, was part of the same unified force that governed electricity and magnetism. Light was simply a wave in the electromagnetic field. The glow of a candle, the rays from the sun, the colors of the rainbow, these were not separate phenomena. They were all manifestations of the same underlying structure that connected electricity and magnetism. Maxwell had uncovered something extraordinary, the unity of nature's forces. What had once appeared as separate islands were now revealed as different expressions of one great continent. Electricity, magnetism, and light were united under a single theory. For the first time in history, humans understood that they lived in a universe governed by interconnected forces, not isolated mysteries. His discovery did more than explain natural phenomena, it transformed them into something predictable and measurable. Invisible forces were no longer beyond comprehension. Maxwell's equations allowed scientists to calculate how fields behaved, how energy moved, and how waves traveled. Forces that had once seemed magical could now be described with mathematical precision. This unification marked one of the most profound turning points in physics. After Maxwell, nothing looked the same. Scientists realized that nature operated through laws far more unified and elegant than anyone had imagined, and Maxwell's work became the foundation upon which future breakthroughs would rise. It influenced everything from the development of radio waves to the birth of modern electronics. Even Einstein relied on Maxwell's ideas as he developed his own theories of relativity. Maxwell's achievement is often compared to Newton's, because just as Newton unified the heavens and the earth with a single law of gravity, Maxwell unified electricity, magnetism, and light with a single framework. But Maxwell's unification was even more far-reaching, because it revealed a hidden realm of waves and fields that would eventually lead to the technologies that define our modern world. Yet the beauty of Maxwell's discovery lies not only in its impact but also in its imagination. He saw connections where none were visible. He built bridges between phenomena that had baffled scientists for centuries. He allowed the human mind to step into the invisible world and understand forces that shape everything around us. His work showed that nature's secrets are not hidden behind impenetrable walls. They are woven into the fabric of reality, waiting for someone with enough curiosity, imagination, and vision to reveal them. And in doing so, Maxwell left behind a legacy that continues to illuminate the path of science today. As Maxwell continued to explore the mysteries of these forces, the world around him was beginning to change. Experiments grew more sophisticated, and interest in electricity grew rapidly. Yet even in this evolving scientific landscape, no one realized how close humanity was to a revolution that would reshape the future. The key to that transformation was hidden in Maxwell's mind, in the way he saw fields. Vast, invisible structures that filled all of space with a quiet but powerful energy. To understand Maxwell's achievement more fully, imagine standing in a time when the very idea of an invisible field was controversial. Many scientists refused to believe that something real could exist without being seen, touched, or measured directly. They wanted mechanical explanations, tiny gears, wheels, or particles pushing each other like clockwork. They wanted the universe to operate like a machine built from small, solid pieces. But Maxwell saw something different. He saw nature as a continuum, a smooth fabric where forces flowed effortlessly, interacting and communicating through space without requiring any physical connection. This perspective was more than a theory, it was a philosophical shift. Maxwell believed that space itself had properties, that fields were not just mathematical tricks, but actual entities with physical meaning. He imagined lines of force stretching across the universe, weaving through air, through matter, even through complete emptiness. These lines were like threads that connected every charge, every magnet, every source of energy, and through this intricate network, electricity and magnetism performed their dance. What made Maxwell so extraordinary was not only his ability to imagine these forces, but his ability to describe them with breathtaking accuracy. His equations captured the essence of how fields behave, how they evolve, and how they influence the physical world. These equations contained within them the seeds of ideas that would one day define technology, communication, and science itself. Yet Maxwell's work was more than mathematical brilliance. It was an act of profound intuition. He had to trust his vision, even when others doubted it. He had to believe that the universe was governed by unity and simplicity, even when the evidence appeared scattered and contradictory. This trust became one of his greatest strengths. It allowed him to see the invisible landscape of forces that had shaped the universe since the beginning of time. As he refined his theory, Maxwell realized that the fields he described were not static. They could rise, fall, ripple, and propagate across space. He imagined them like waves in an unseen ocean, vibrant and full of energy. When he calculated the speed of these waves, he discovered an astonishing truth: their speed matched precisely the measured speed of light. This was no coincidence. Maxwell saw that light itself was an electromagnetic wave, a ripple traveling through the fabric of the electromagnetic field. This discovery reshaped humanity's understanding of the natural world. Light was no longer a mysterious phenomenon, separate from electricity and magnetism. It was part of a single story, the story of a unified force that governed everything from the glow of stars to the flicker of a simple flame. Maxwell showed that the visible and invisible realms were connected, that nature's forces were not separate kingdoms, but intertwined expressions of a deeper and more beautiful reality. The impact of this insight spread far beyond physics. It changed how humans perceive the universe. It suggested that nature operated through harmony, through relationships, through the interplay of fields and waves. It hinted at a cosmic order that lay beneath every phenomenon, waiting for those with enough imagination to uncover it. Maxwell's equations did something even more profound. They predicted possibilities no one had imagined. They implied that electromagnetic waves could travel through space far beyond the range of light, at frequencies invisible to the human eye. These waves, if produced and detected, could carry information across great distances. Although Maxwell never lived to see it, his work foretold the invention of radio, wireless communication, television, and countless technologies that shape modern life. The voices and images that today travel effortlessly through the air, the signals that carry data across continents, the invisible networks that allow billions to stay connected. All of them trace their origins back to Maxwell's vision. What makes this achievement so remarkable is how deeply it changed the scientific worldview. Before Maxwell, physics was divided into separate branches, each with its own rules and mysteries. After Maxwell, a new picture emerged, one in which forces were unified and fields became central to the structure of reality. This shift paved the way for future generations of scientists to explore deeper questions about space, time, and energy. Maxwell's work became a stepping stone to the theories that shaped the 20th century. Einstein relied heavily on Maxwell's equations as he developed his theory of relativity, calling them the most profound and the most fruitful of all scientific discoveries. Quantum physics, too, owes much to the field concepts Maxwell introduced, but beyond its scientific significance, Maxwell's story is a testament to human imagination and perseverance. He accomplished his groundbreaking work during an era when scientific instruments were limited, when communication between researchers was slow, and when skepticism often overshadowed innovation. Yet Maxwell refused to be constrained by what others could not see. He trusted the patterns he found in nature. He believed that hidden beneath the surface of every phenomenon was a unity waiting to be revealed. This belief became the driving force behind his discoveries. Maxwell's life itself was humble and quiet. He was not a flamboyant scientist seeking fame or recognition. He was a thinker, deeply curious and endlessly patient. He spent hours studying, calculating, and revisiting ideas until they aligned with his intuition. His dedication was born not of ambition, but of genuine wonder. The universe fascinated him, and he approached it with the reverence of someone who believed that every law of nature carried meaning. His ability to blend imagination with mathematical precision made him one of the greatest scientific minds in history. Yet for many years, his contributions were overshadowed by the more dramatic discoveries of others. Only with time did the world fully grasp the magnitude of his achievement. Today, Maxwell is celebrated as the bridge between classical physics and modern physics, the mind who saw the underlying unity of forces and brought order to what had once been a scattered landscape of ideas. If one reflects on the world today, it becomes impossible to ignore Maxwell's influence. Every streetlight, every radio signal, every electronic device, every satellite orbiting Earth carries a trace of his ideas. The technologies that define modern civilization, the power grids that illuminate cities, the communication systems that connect nations, the scientific instruments that explore the universe, all rely on principles Maxwell described more than a century ago. His work also laid the foundation for understanding the universe at its deepest levels. By revealing the nature of electromagnetic waves, he opened the door to new explorations of the cosmos. Telescopes that capture radio waves, microwaves, and infrared signals operate using principles derived from Maxwell's theory. Through them, humans have looked farther into space than ever before, observing galaxies, nebulae, and cosmic phenomena invisible to the eye. Maxwell's vision gave humanity more than scientific understanding. It gave us a new way to see the universe. As the 19th century came to an end, Maxwell's ideas became woven into the fabric of scientific thought. The unity he revealed transformed the study of nature, turning it from a collection of isolated mysteries into a coherent and interconnected whole. Scientists began to see patterns where they once saw complexity, connections where they once saw contradictions. Maxwell had given them a new lens, one through which the invisible forces of the universe could be studied, understood, and harnessed. In the end, Maxwell's achievement stands not only as a triumph of intellect, but as a celebration of human curiosity. He proved that the invisible is not unknowable. He showed that patience, imagination, and insight could illuminate the deepest structures of reality. His theories remain as relevant today as when he first proposed them, continuing to inspire scientists, engineers, and thinkers across the world. Maxwell saw a universe alive with motion, filled with fields that vibrated, connected, and communicated in ways that no one had ever imagined. And by revealing this hidden world, he changed the course of human history. His legacy is not just the science he left behind, but the spirit with which he explored the unknown. A spirit that continues to guide those who seek to understand the universe and the invisible forces that shape it. The universe hums with forces that cannot be seen. Long before they were measured or harnessed, they moved silently, shaping the world around us. For most people, these forces were abstract, intangible, and impossible to grasp. Yet James Clerk Maxwell, a man of extraordinary insight, could perceive them in ways that transformed science forever. He understood that the invisible was not a void or emptiness, but a dynamic landscape full of energy, motion, and interaction. He realized that the forces acting on matter were hidden in plain sight, governing everything from the tiniest spark of electricity to the vast light of the stars. In Maxwell's time, the notion that invisible forces could control the physical world was revolutionary. People had observed electricity flicker in sparks, magnets draw iron toward themselves, and light illuminate the darkness. But the principles that linked these phenomena were elusive. Science had made progress in cataloging these effects, yet few dared to imagine that they were all part of a unified system. Maxwell's genius lay in his ability to envision this unity. He saw the unseen threads that tied the universe together and used mathematics to give them form, structure, and predictability. Imagine standing in a darkened room with no sense of the wind, the air, or the magnetic pull of the earth. Yet invisible forces are at work, guiding, influencing, and shaping every moment. Maxwell's insight was that these forces could be understood, even if they could not be touched or seen directly. He envisioned fields of influence radiating through space, lines of force stretching from one particle to another, forming an intricate network that governed matter and energy alike. These fields were not abstract, they had tangible effects. They moved objects, generated light, and produced energy. In essence, they were the hidden scaffolding of reality. Maxwell did not rely solely on observation. He combined the precision of mathematics with the imagination of a visionary. He translated the behaviors of electricity and magnetism into equations that captured their essence. These equations were not just tools. They were a language that described the invisible world, a way to read the hidden codes of nature. By doing so, Maxwell transformed phenomena that had once seemed mysterious into predictable, measurable, and universal laws. His approach required a profound shift in perspective. Previously, forces were thought to act only through direct contact, through tangible pushes and pulls. Maxwell proposed a more subtle vision that fields permeated space, independent of matter, yet capable of exerting influence. This idea was difficult to accept. It challenged the conventional wisdom of centuries. Yet as Maxwell developed his theory, the predictions it made aligned perfectly with observed phenomena. Sparks followed patterns, magnets exerted forces as expected, and light behaved in ways that revealed its connection to electromagnetic waves. Slowly, the invisible became comprehensible, measurable, and, most importantly, actionable. One of Maxwell's key insights was the recognition that invisible forces are dynamic, constantly in motion, and self-sustaining. He discovered that changes in electric fields generate magnetic fields, and changes in magnetic fields generate electric fields. This interdependence meant that energy could propagate through space as waves, independent of any medium or material substance. It was a concept that expanded the imagination of scientists and opened the door to a new understanding of the natural world. For the first time, humanity had a framework for thinking about forces that travel invisibly, silently, and yet powerfully across the universe. The implications of this discovery were immense. If forces could travel through empty space, if they could transmit energy and information without direct contact, then the universe was far more interconnected than anyone had imagined. Light, electricity, and magnetism were not isolated phenomena, they were different expressions of the same fundamental laws. Maxwell realized that these forces could not only explain the behavior of physical systems on Earth, but also describe processes occurring across the cosmos. Stars, planets, and galaxies were all influenced by these invisible energies, creating harmony, rhythm, and order throughout the universe. Maxwell's insight also revealed the predictive power of understanding invisible forces. Once he described the interactions of electric and magnetic fields mathematically, he could anticipate phenomena that had never been observed. For example, his equations implied the existence of electromagnetic waves traveling through space at a specific speed. This was a profound revelation, suggesting that signals, energy, and information could traverse vast distances without any material conduit. The discovery was theoretical at first, but it laid the groundwork for technologies that would revolutionize human civilization, including radio, television, and modern wireless communication. Perhaps most remarkable was Maxwell's ability to connect the invisible with the visible. He demonstrated that light itself was an electromagnetic wave, a tangible manifestation of the invisible forces that he had described. The sunlight warming our faces, the glow of a candle, the flicker of a distant star, all were expressions of the same hidden currents and fields he had uncovered. This insight did more than explain light. It showed that the world we perceive is intertwined with layers of energy and interaction beyond ordinary perception. The universe was no longer a collection of isolated events, it was a coherent, interconnected system governed by principles that could be understood, even if not directly seen. Maxwell's work also highlighted the universality of these invisible forces. They were not limited to a single type of material or localized environment. They existed everywhere, affecting all matter and energy. The same principles applied to magnets in a laboratory, the currents in a wire, the rays of the sun, and the stars scattered across the sky. His vision was expansive, encompassing the smallest sparks and the largest cosmic phenomena. By recognizing the omnipresence of these forces, Maxwell elevated the study of nature from a catalog of observations to a unified scientific narrative. In addition, Maxwell's revelations underscored the importance of conceptual imagination in science. He demonstrated that true understanding often requires thinking beyond what can be directly observed. By visualizing fields, interactions, and waves, he allowed the human mind to grasp phenomena that had previously seemed impossible to comprehend. His equations provided a bridge between thought and reality, showing that imagination, combined with rigorous analysis, can unveil truths about the universe hidden from ordinary perception. Maxwell's exploration of invisible forces also reshaped the scientific method itself. He proved that observation alone was insufficient. It needed to be combined with theory, abstraction, and predictive reasoning. Through careful experimentation and imaginative modeling, Maxwell created a framework that could anticipate and explain phenomena long before they were observed. His work illustrated the power of connecting theory and practice, demonstrating that understanding the invisible is essential for mastering the visible. The elegance of Maxwell's approach lay in its simplicity and coherence. Rather than producing a fragmented set of rules for each separate phenomenon, he unified electricity, magnetism, and light under a single set of principles. This unification revealed that what appears complex on the surface often arises from simple, underlying patterns. By focusing on the invisible forces that govern reality, Maxwell showed that science can transform confusion into clarity, mystery into knowledge. Finally, Maxwell's vision emphasizes the importance of curiosity and persistence in uncovering nature's secrets. He spent years refining his equations, rethinking assumptions, and challenging conventional ideas. He pursued a path few dared to tread, motivated not by fame or recognition, but by an insatiable desire to understand the hidden workings of the universe. In doing so, he demonstrated that the invisible is not beyond reach. It simply requires a mind willing to look beyond the surface and explore the deeper layers of reality. The story of Maxwell's discovery is not only a story of science, but also a story of perception, of seeing what others could not, of sensing the invisible threads that shape reality. He understood that the universe is not a collection of isolated events, but a web of relationships, a network of influences, a dynamic tapestry in which energy and matter interact through unseen forces. These forces were not abstractions, they had consequences, measurable and profound, affecting everything from the smallest particle to the largest celestial body. Maxwell's genius lay in his ability to reveal these connections, to give form to the invisible, and to show humanity the structure that lies beneath the apparent chaos of the world. Imagine standing in a room where invisible currents flow past you in every direction. Every flicker of light, every movement of a charged particle, every ripple of energy is part of a grand pattern, invisible to the naked eye, but real in its effects. Maxwell's equations allowed scientists to see this pattern, to understand the rules that govern these forces, and to predict how they would behave under a vast range of circumstances. He transformed the intangible into something tangible, the hidden into something measurable, the mysterious into something scientific. Maxwell's insight also challenged the human imagination. To understand his theory required thinking in terms of fields rather than particles, in terms of continuous energy rather than discrete objects. He asked humanity to consider that the air around us is not empty, but a medium in which invisible energies flow, interact, and propagate. Each electric charge, each magnet, each photon of light is connected to a wider universe through these fields. In this framework, forces are not localized or arbitrary, they are part of a coherent, interconnected system. This was a profound shift in the way humans understood nature. His realization that invisible forces could transmit energy over vast distances opened the door to a world that had previously existed only in the imagination of dreamers and inventors. If energy and information could travel without wires, if light and electromagnetic waves were one and the same, then the potential for communication and technology was limitless. Maxwell's work laid the theoretical foundation for radio waves, wireless communication, television, and eventually the entire digital world. All of these developments which shape modern life rely on the invisible principles he uncovered. Moreover, Maxwell's work bridged the gap between theory and observation in a way that few scientists had achieved before. He combined mathematical precision with physical intuition, predicting phenomena that would be experimentally confirmed decades later. Electromagnetic waves were first demonstrated experimentally by Heinrich Hertz in the late 19th century, decades after Maxwell had formulated his equations. Yet, it was Maxwell who had first revealed their existence in the language of mathematics, seeing the invisible before anyone could measure it. This is a testament not only to his intellect, but to his extraordinary vision, his ability to trust insight over immediate empirical proof. Another remarkable aspect of Maxwell's approach was its universality. The forces he described were not confined to a laboratory experiment or a particular material. They existed everywhere. They governed the flow of energy through wires, the propagation of light from distant stars, and the behavior of the entire cosmos. His insight showed that invisible forces are not local phenomena, but universal principles. From the smallest spark in a lab to the vast luminosity of galaxies, the same laws apply. This revelation transformed physics, giving it a coherence and unity that allowed subsequent generations of scientists to explore deeper mysteries with confidence. Maxwell's exploration of invisible forces also influenced philosophy and human understanding in profound ways. He challenged the notion that only the tangible, the visible, or the immediately measurable could be considered real. By showing that fields and waves, although unseen, had real and predictable effects, he expanded the boundaries of what humans could comprehend. He demonstrated that reality is more than what the senses perceive, that layers of hidden energy and interaction exist beyond immediate perception. This idea resonates beyond physics, suggesting that understanding often requires looking beyond appearances to grasp the deeper structure of things. The dynamic nature of these invisible forces fascinated Maxwell. Unlike static objects, fields are alive with motion, constantly interacting, influencing, and creating patterns. Electric fields generate magnetic fields generate electric fields. Together, they propagate as waves through space. Maxwell's insight transformed the invisible from a passive background into a vibrant, active medium in which energy moves and communicates. This vision made it possible to imagine a universe in which information, light, and energy could traverse immense distances, connecting points that appeared disconnected at first glance. Maxwell's legacy is also a testament to the power of curiosity and perseverance. His theories were not the result of a single eureka moment, but of years of patient observation, careful calculation, and relentless questioning. He challenged assumptions, examined contradictions, and refined ideas until they aligned with both logic and evidence. This method, combining imagination with rigor, remains a guiding principle in scientific discovery. By showing that invisible forces can be understood and predicted, Maxwell taught humanity to trust in the power of intellect and observation, even when dealing with phenomena that cannot be directly seen. His vision extended to light itself, transforming it from a mysterious, intangible phenomenon into a manifestation of the electromagnetic field. Sunlight, candlelight, the glow of distant stars, all were no longer isolated occurrences, but expressions of the same invisible principles that govern electricity and magnetism. This unification not only explained the behavior of light, but also demonstrated the coherence of nature, revealing a universe structured by interdependent forces. Maxwell's equations allowed humans to comprehend phenomena across scales, from the smallest laboratory apparatus to the farthest reaches of the cosmos. The predictive power of understanding invisible forces became clear as scientists applied Maxwell's ideas to technology. Wireless communication, radar, and even modern electronics operate on principles that he uncovered more than a century ago. By grasping how electric and magnetic fields propagate and interact, humanity gained the ability to manipulate energy and information, to transmit signals across continents, and to connect the world in ways once thought impossible. These achievements, now taken for granted, all trace their roots to Maxwell's vision of invisible, interconnected forces. Maxwell also showed that the universe is governed by elegant simplicity. Beneath the complexity of natural phenomena, there exist fundamental patterns and principles that explain a wide range of behaviors. By focusing on the underlying forces rather than superficial events, he revealed that what seems mysterious is often part of a consistent and harmonious system. This insight reshaped not only physics, but also the way humans think about patterns, relationships, and causality. The invisible became a lens through which the visible world could be understood in its full coherence. Furthermore, Maxwell's work inspired a new way of teaching and conceptualizing science. Instead of presenting isolated facts, he encouraged the understanding of systems and interactions. By emphasizing the invisible connections between phenomena, he provided a framework that nurtured creativity, exploration, and innovation. Students and researchers learned to imagine fields, visualize waves, and think in terms of relationships rather than discrete objects. This approach has influenced generations of scientists and continues to be foundational in modern physics education. Finally, Maxwell's exploration of invisible forces reminds humanity of the profound beauty inherent in nature. The fact that unseen fields govern the behavior of everything around us, from the simplest electrical circuit to the distant light of galaxies, illustrates a universe more intricate and harmonious than casual observation reveals. Maxwell's ability to reveal this hidden order transformed science from mere measurement into a form of wonder, showing that understanding the invisible can also deepen appreciation for the visible. In the end, Maxwell's work is a testament to the power of vision, imagination, and rigorous thought. He taught humanity that the invisible is not unreachable, that hidden forces can be understood, measured, and harnessed. Through his equations, he revealed the dynamic, interconnected structure of the universe and showed that forces beyond perception govern the world in ways both predictable and profound. His legacy continues to inspire, reminding us that there is always more to see, even in what cannot be directly observed, and that the invisible can be as real, as powerful, and as beautiful as anything we can touch or see. The world of light, though familiar to every human eye, had long been a mystery in the eyes of science. For centuries, people marveled at its brilliance, its colors, and its warmth, yet few understood its nature. It was a phenomenon that could illuminate, guide, and inspire, but it remained untouchable, seemingly separate from the other forces of the universe. James Clerk Maxwell changed that forever. He revealed that light was not an isolated spectacle, but a natural consequence of the fundamental forces that permeate reality. He saw the invisible patterns that orchestrated its behavior, and in doing so, he transformed human understanding of both the visible and invisible worlds. Before Maxwell, light had been studied in terms of its reflections, refractions, and diffraction. Scientists could describe how lenses bend it, how mirrors reflect it, and how prisms divide it into a rainbow of colors. But these studies, while practical, did not reveal the underlying nature of light itself. It remained a puzzle, a force that seemed to act according to its own mysterious rules. Maxwell, however, looked beyond these observable effects. He sought to uncover the mechanism behind light, the fundamental principle that governed its existence. He did not just study what light did. He asked why it behaved as it did, and how it related to the forces that had long been considered separate from it. Through his meticulous study of electricity and magnetism, Maxwell began to notice a profound connection. He realized that the interplay of electric and magnetic fields could generate waves that propagate through space. These waves were not mere mathematical constructs, they represented real, physical phenomena. Energy could travel invisibly through the medium of space, carried by the alternating dance of electric and magnetic forces. When Maxwell calculated the speed at which these waves would travel, he was astonished to find that it matched precisely the measured speed of light. In that moment, light ceased to be a mysterious force. It was revealed as an electromagnetic wave, a tangible manifestation of invisible fields in motion. This discovery was more than a scientific revelation, it was a paradigm shift. Light was no longer a unique or isolated phenomenon. It was part of the universal language of energy and forces, bound by the same rules that governed electricity and magnetism. Sunlight streaming through a window, the glow of a firefly, the shimmer of a distant star, all were expressions of a single, unified principle. Maxwell had revealed that the behavior of light could be predicted, understood, and integrated into a larger framework of natural law. The invisible mechanisms behind light were now measurable and describable, and the universe seemed suddenly more comprehensible. Maxwell's insight required a level of imagination few scientists could muster. To see light as an electromagnetic wave meant envisioning something that could not be touched, seen in its entirety, or fully comprehended by the senses. It required the ability to think in terms of invisible fields, in terms of oscillating energies moving through the emptiness of space. He visualized the electric field rising and falling, generating a magnetic field in response, which in turn created an electric field, and so on, a self-sustaining wave that carried energy across the void. In this dance, light became not an anomaly but a natural expression of the interplay of forces. Maxwell could see what others could not, the invisible architecture that underlies the visual spectacle of the world. The realization that light was an electromagnetic wave also had profound implications for understanding the universe. It suggested that many phenomena previously considered separate could be related through the same fundamental laws. Just as electricity and magnetism were manifestations of the same force, so too was light part of this grand unification. Maxwell's insight laid the foundation for an entirely new way of thinking about the cosmos, one in which energy flows through fields, waves propagate invisibly, and the forces that govern matter are interconnected. Every photon of light, from the faint glow of distant stars to the brilliance of the midday sun, was now seen as part of this invisible, orderly framework. This understanding also opened the door to technological innovation. By recognizing that light was an electromagnetic wave, scientists could begin to manipulate electromagnetic energy in ways previously impossible. The concept of electromagnetic waves traveling through space became the theoretical basis for the development of radio waves, television signals, and eventually all forms of wireless communication. What Maxwell discovered in his equations more than a century ago now underpins the technology that connects billions of people across the globe. Every fiber optic cable, every radio tower, every satellite beacon carries the legacy of this revelation, translating invisible waves into visible and tangible effects. Maxwell's discovery also bridged the gap between abstract mathematics and physical reality. His equations were not just symbolic representations. They described real processes that could be observed, tested, and verified. By showing that light is a natural outcome of electromagnetic fields, he demonstrated the predictive power of theoretical science. His work transformed the study of physics from a collection of isolated experiments into a coherent framework capable of explaining both familiar and unseen phenomena. The light that illuminates our world could now be understood not just in its behavior, but in its origin. as an inevitable consequence of the invisible interplay of forces. Furthermore, Maxwell's vision emphasized the universality of natural law. The same principles that govern light in a laboratory also govern sunlight traveling millions of miles across the cosmos. The behavior of light is consistent, predictable, and connected to the broader framework of electromagnetic phenomena. By revealing this universality, Maxwell transformed humanity's understanding of the natural world, showing that the same invisible principles operate on all scales, from the microscopic interactions of particles to the macroscopic light traveling across galaxies. Light became not just a physical phenomenon, but a symbol of the underlying unity of nature. Another remarkable aspect of Maxwell's discovery was the conceptual leap it represented. To see light as an electromagnetic wave required thinking beyond direct perception, beyond what the senses alone could tell us. It required trusting in the invisible, believing that patterns and relationships exist, even if they are not immediately observable. Maxwell's work demonstrated that reality is layered. The visible is only a surface expression of deeper, interconnected forces. By revealing this hidden layer, he showed that science is not merely about cataloging what we can see, but about uncovering the principles that govern the unseen, the forces that animate the world at its most fundamental level. Maxwell's insight also had aesthetic and philosophical resonance. Light, once a mysterious and poetic element of human experience, became an expression of universal order. The harmony between electricity, magnetism, and light suggested a universe more elegant and interconnected than previously imagined. Maxwell's equations showed that the cosmos is governed by principles that are both beautiful and comprehensible, that the invisible can have tangible consequences, and that what appears mysterious often has an underlying logic waiting to be discovered. The revelation that light is an electromagnetic wave was not only a triumph of physics, but a celebration of the coherence and elegance of the natural world. The journey to this understanding was neither simple nor straightforward. It required decades of careful observation, deep mathematical insight, and the courage to challenge existing paradigms. Maxwell meticulously analyzed experiments, synthesized the work of earlier scientists, and created a framework that unified disparate phenomena. He relied on both rigorous calculation and intuitive visualization, bridging the gap between abstract theory and empirical reality. In doing so, he showed that light, electricity, and magnetism were not separate curiosities, but interconnected threads in the same grand tapestry. Maxwell's work on light also paved the way for the next generations of physicists to explore phenomena beyond the visible spectrum. By recognizing that electromagnetic waves exist at many frequencies, not all of which are detectable by the human eye, he expanded the concept of radiation and energy. This realization allowed for the discovery of radio waves, microwaves, X-rays, and gamma rays, forms of light invisible to our senses, but governed by the same underlying principles. Maxwell's equations thus opened a new frontier, a world of invisible light that would transform science, medicine, communication, and technology. In essence, Maxwell revealed that light is both ordinary and extraordinary. It is the sunlight that nurtures life and the electromagnetic wave that carries information across continents. It is the familiar glow of a candle and the foundation of modern communication. By showing that light is a manifestation of invisible forces, Maxwell brought order to a phenomenon that had fascinated humanity for millennia. He transformed it from a mysterious, separate entity into a fundamental expression of the universal forces that govern all matter and energy. Maxwell's discovery also underscores the interconnectedness of knowledge. By linking light to electromagnetic fields, he demonstrated that understanding one domain can illuminate another. The study of electricity and magnetism was no longer confined to the laboratory. It became a key to understanding the very nature of light, and by extension, the structure of the universe itself. His work exemplifies the power of synthesis, of seeing relationships where others perceive separation, and of trusting that the invisible threads of reality can be revealed through careful thought, imagination, and rigorous analysis. As Maxwell's work on light unfolded, it became clear that his discovery was not merely a scientific achievement, but a profound revelation about the nature of reality itself. Light, once seen as a mere phenomenon, became a tangible expression of the invisible architecture of the universe. Every ray of sunlight, every flicker of fire, every beam that illuminates a distant star was now understood as a manifestation of electromagnetic fields interacting in precise, predictable ways. Maxwell had unlocked the principle that these forces, though invisible, could be traced, described, and even predicted, revealing the hidden structure that governs the cosmos. This understanding transformed the perception of light from something mystical to something fundamentally logical. Humans had long associated light with perception, warmth, and life, but now it could also be studied as a physical phenomenon governed by universal laws. Maxwell showed that the seemingly intangible could be expressed in mathematical form, that the unseen could be rendered comprehensible. By linking light to the oscillating interaction of electric and magnetic fields, he demonstrated that nature operates according to principles far more unified and elegant than previously imagined. This unification allowed scientists to see light not as an isolated curiosity, but as an integral part of the broader framework of natural forces. The predictive power of Maxwell's insight cannot be overstated. By understanding that light is an electromagnetic wave, humanity could foresee phenomena that had yet to be observed. Heinrich Hertz's experiments decades later confirmed the existence of radio waves, waves that are fundamentally the same as visible light, but outside the range of human sight. This realization opened a gateway to technologies that now define modern life: radio, television, radar, and all forms of wireless communication. Every transmission of information through space, every invisible signal traveling across vast distances, is a direct consequence of the principles Maxwell uncovered. His vision revealed a hidden world of energy and interaction, a realm that had existed since the dawn of time but had remained unnoticed until his equations illuminated it. Maxwell's approach required an extraordinary combination of imagination and analytical rigor. He visualized fields and waves that no one could see, describing their motion and behavior with unprecedented precision. His work demonstrated that understanding the invisible requires more than observation. It requires the ability to conceptualize forces and interactions that lie beyond immediate perception. He showed that the universe contains layers of complexity, and that human understanding depends on the capacity to see beyond the surface. Light, as he revealed, is both a familiar and a hidden phenomenon, one that operates according to laws that govern all electromagnetic interactions. The implications of this insight were profound for both science and technology. Maxwell's revelation allowed engineers and scientists to manipulate electromagnetic waves, creating tools and devices that extend human perception and ability. Light could be harnessed, transmitted, and used to convey information. The discovery that electromagnetic waves travel through space opened possibilities that had seemed fantastical. Messages sent across oceans without physical connection, signals transmitted through the air, energy propagated invisibly yet predictably. In this sense, Maxwell's work did not just explain light. It unlocked the potential for human innovation, linking theoretical understanding with practical application in ways previously unimaginable. Moreover, Maxwell's insight offered a new perspective on the interconnectedness of natural phenomena. Electricity, magnetism, and light were no longer separate forces, they were expressions of the same underlying principle. This revealed a universe governed by unity rather than fragmentation, coherence rather than randomness. It suggested that nature operates according to patterns that can be understood through careful observation, theoretical insight, and mathematical expression. Light, once considered ephemeral and separate, became a symbol of this unity, a tangible manifestation of invisible laws that govern the behavior of all matter and energy. The conceptual leap required to understand light as an electromagnetic wave was immense. Humans experience light every day, yet its nature cannot be directly observed without scientific insight. Maxwell's equations revealed the hidden rhythms and structures behind what we see, allowing a glimpse into the invisible processes that orchestrate reality. Electric fields rise and fall, creating magnetic fields. Magnetic fields in turn generate electric fields, producing waves that propagate through space. These waves are not static, they are dynamic, self-sustaining, and capable of carrying energy across vast distances. Maxwell transformed the perception of light from a mere visual phenomenon into an active process, governed by predictable and measurable laws. This discovery also had profound implications for understanding the cosmos. Light, as an electromagnetic wave, travels across the vacuum of space, linking distant stars, galaxies, and planets. By revealing the underlying principles of light, Maxwell provided humanity with the tools to interpret signals from the universe, to understand the behavior of celestial objects, and to explore realms far beyond Earth. Telescopes that detect not only visible light but also radio waves, infrared, and other electromagnetic frequencies rely on the principles he uncovered. His work allowed humans to reach farther into space than ever before, to observe the invisible, and to understand phenomena that were previously inaccessible. Maxwell's insight also highlighted the importance of abstraction and imagination in scientific discovery. Understanding light as an electromagnetic wave required thinking beyond what could be seen or touched. It required conceptualizing invisible fields and predicting their behavior. Maxwell demonstrated that the deepest truths of nature often lie beyond direct perception, and that science is as much about imagination as it is about observation. By embracing the invisible, he expanded the scope of human understanding, showing that reality is layered and interconnected, and that comprehension requires looking beyond the surface to grasp the underlying structures. Furthermore, Maxwell's work revealed the intrinsic elegance of natural laws. The same equations that describe the propagation of light also explain the behavior of electric and magnetic fields in countless other contexts. The universe, he showed, operates according to principles that are simple, unified, and consistent across scales. From the flicker of a candle to the glow of a distant quasar, the same laws apply. This universality transformed human understanding, offering not only explanation but also coherence, showing that the apparent complexity of nature emerges from underlying simplicity and order. The technological ramifications of this understanding are immense. Modern communications, from radio to Wi-Fi to satellite transmissions, all depend on manipulating electromagnetic waves, a principle first articulated through Maxwell's insight into light. Medical imaging technologies, such as X-rays and MRI, rely on understanding light and electromagnetic radiation. Even lasers, which underpin countless industrial, scientific, and consumer technologies, operate on principles Maxwell helped reveal. In essence, his work turned the invisible forces of light into tools for shaping, exploring, and understanding the world. Maxwell's revelation also transformed philosophical perspectives on perception and reality. Light, once an element of sensory experience alone, became a bridge between the visible and the invisible, showing that what humans perceive is only a part of the universe's full story. Invisible forces shape reality in ways that can be understood and predicted, even if they cannot be directly seen. By studying these forces, humans gain not only practical knowledge, but also insight into the fundamental order of the cosmos. Maxwell taught that understanding the unseen is as critical as understanding the observable, and that science provides a means to access that hidden realm. His work demonstrated that the universe is alive with motion and energy, constantly interacting through fields and waves. Light is the most familiar expression of this motion, yet it is only one part of a vast continuum of electromagnetic activity. Maxwell's equations describe this continuum, showing how forces interact, propagate, and manifest in phenomena ranging from the mundane to the cosmic. By revealing these principles, he allowed humanity to see the universe in a new light, literally and figuratively, understanding that visible illumination is part of a broader, interconnected network of energy and force. Maxwell's vision of light also underscores the power of persistence and intellectual courage. His insights were not immediately obvious, and they challenged prevailing assumptions. He synthesized decades of experimental observations, developed new mathematical frameworks, and trusted his intuition about the invisible workings of the universe. In doing so, he revealed that understanding nature often requires venturing beyond the familiar, imagining what cannot be directly seen, and rigorously testing those ideas through reasoning and calculation. Finally, Maxwell's work illustrates the profound beauty of science. By showing that light is an electromagnetic wave, he unified disparate phenomena, revealed hidden patterns, and provided humanity with a deeper comprehension of the cosmos. The glow of sunlight, the colors of a sunset, the faint light from distant stars, all are part of this invisible structure, governed by laws that Maxwell illuminated. His discovery transformed not only physics, but human perception, showing that the universe is coherent, interconnected, and full of patterns that are both comprehensible and astonishing. In the end, Maxwell's revelation about light exemplifies the transformative power of insight. He turned an everyday phenomenon into a gateway for understanding invisible forces, predicted phenomena that would later revolutionize technology, and provided a framework for exploring both the observable and hidden aspects of reality. His vision continues to shape science, technology, and human understanding, reminding us that the visible world is only a fraction of the universe's full story, and that the invisible threads woven through space are as vital, powerful, and beautiful as the light they carry. Even in a world increasingly illuminated by science, some forces remained elusive, hidden behind layers of perception and understanding. Maxwell had the extraordinary ability to perceive these subtle, invisible interactions, recognizing that the fabric of reality is threaded with forces that operate beyond ordinary sight. He understood that every object, every movement, and every phenomenon is influenced not just by contact or visible action, but by dynamic fields extending through space. These fields are the silent architects of the universe, shaping motion, energy, and light in ways that are imperceptible yet profound. Through careful observation and imaginative insight, he revealed that the space surrounding matter is not empty, but a medium in which energy moves and interacts. Electric and magnetic forces flow through this space, constantly generating, influencing, and responding to one another. What seems static or inert is, in fact, alive with activity. These forces ripple invisibly, propagating energy across vast distances, linking objects and phenomena that appear disconnected. In this way, Maxwell transformed the concept of force from a mere push or pull into an expansive and dynamic network of interaction. He also discovered that the effects of these invisible forces are predictable and measurable. By representing them mathematically, he could describe the precise behavior of fields and waves, showing how energy is transferred and transformed. This ability to quantify the invisible was revolutionary. It meant that forces once regarded as mysterious could be understood, harnessed, and applied. His equations became a map of the unseen, revealing currents and vibrations that shape reality at every scale, from the flicker of a spark in a laboratory to the light traveling from distant stars. Beyond prediction, these insights highlighted the interconnectedness of natural phenomena. Electricity, magnetism, and light are not separate occurrences, but interwoven expressions of the same underlying principles. Maxwell's vision revealed that what appears disparate or unrelated often stems from the same hidden patterns. The universe, he showed, operates as a coherent system in which invisible forces organize, coordinate, and drive the behavior of matter and energy. Every motion, every wave, and every beam of light is part of this larger, harmonious framework. His work also emphasized the importance of conceptual imagination in science. Seeing the invisible required a mind willing to visualize forces and interactions beyond the reach of direct observation. Maxwell imagined fields stretching through space, oscillating and interacting, forming waves that carry energy across vast distances. This approach illustrated that understanding the universe often demands insight, creativity, and intuition, alongside rigorous calculation and observation. The invisible, once considered inaccessible, became a landscape to explore, describe, and predict. Moreover, the implications of these invisible forces extend beyond theory. They underpin technologies that define modern life, from electrical grids to wireless communication, from medical imaging to satellite networks. The movement of energy and information through space, guided by these principles, has reshaped human society. Maxwell's vision revealed that understanding the invisible is not merely a matter of curiosity, but a foundation for innovation, discovery, and progress. Ultimately, his work conveys a profound lesson: reality is far more interconnected and dynamic than it appears. The unseen forces that surround us shape every interaction, guide every wave of energy, and link the distant corners of the universe. By illuminating these hidden patterns, Maxwell offered humanity a new lens through which to perceive and understand the world, a vision in which the invisible is not only real, but essential to the very structure of existence. The world of natural forces is a realm often hidden from the naked eye, yet it governs every aspect of existence. Maxwell perceived this intricate web of influence, understanding that energy and motion are not confined to the visible or tangible. He recognized that forces act across space, shaping matter, light, and magnetism in a continuous interplay that connects even the most distant phenomena. His insight revealed a universe alive with interaction, where nothing exists in isolation, and every event is linked to invisible currents flowing unseen through the cosmos. Through meticulous study and creative imagination, he saw that electric and magnetic fields are not merely localized effects but extend through space, forming a dynamic network that carries energy and information. These fields interact in predictable ways, creating waves that propagate across vast distances. Light, electricity, and magnetism are expressions of this same underlying principle. By understanding these interactions, Maxwell illuminated the hidden architecture of the universe, showing that even phenomena that appear separate are intimately connected. This understanding brought coherence to observations that had long seemed disconnected or mysterious. Electrical sparks, magnetic attraction, and the propagation of light were once regarded as unrelated events, each requiring its own explanation. Maxwell revealed that they are all governed by the same fundamental rules. His equations allowed scientists to predict behaviors, calculate effects, and describe patterns that were previously invisible and seemingly unknowable. Through this framework, the invisible forces became comprehensible, measurable, and applicable, laying the foundation for future scientific and technological advances. Maxwell's vision also emphasized the dynamic nature of these forces. Unlike static objects, fields are constantly in motion, interacting with one another and propagating energy. A changing electric field generates a magnetic response, which in turn produces a new electric effect, creating a self-sustaining cycle that moves through space. These oscillations, invisible to the human eye, form the basis of waves that carry energy across vast distances. It was through this insight that he could demonstrate the nature of light as an electromagnetic phenomenon, revealing a universe in which motion, energy, and force are fundamentally intertwined. The implications of this insight extend far beyond theory. By understanding the behavior of invisible fields, humanity gained the ability to manipulate energy and information in unprecedented ways. Technologies such as electrical grids, radio transmission, wireless communication, and modern computing rely on principles that Maxwell described. The invisible becomes not just understandable, but useful, a medium through which human society can expand its capabilities, connect across distances, and explore previously unreachable realms. His work showed that understanding hidden forces is not merely a theoretical pursuit, but a practical gateway to innovation. Moreover, Maxwell's insights demonstrate the elegance and order inherent in the universe. What appears chaotic or random on the surface is often the result of deeper, predictable patterns. The invisible forces he described operate with remarkable consistency, linking phenomena across scales, from the behavior of electrons in a conductor to the light traveling from distant stars. This universality highlights a cosmos governed by interconnected principles, where invisible forces are the scaffolding upon which the visible world is built. Perhaps most profoundly, Maxwell's work reveals the importance of imagination and vision in science. Seeing the invisible required him to think beyond observation, to visualize forces, waves, and interactions that could not be directly sensed. By trusting in patterns that others could not yet perceive, he bridged the gap between theory and reality, showing that curiosity, insight, and persistence can illuminate even the most hidden aspects of nature. His discoveries remind us that much of the universe operates beyond immediate perception, yet can be understood through careful thought, creativity, and mathematical rigor. In essence, Maxwell taught that the unseen is not void or absence, but a dynamic, vibrant domain of forces that shape reality. Every wave, every current, every photon is connected to this invisible framework, creating a universe in which nothing is isolated and everything is interrelated. By revealing these hidden patterns, Maxwell provided humanity with a lens to see the world more deeply, to understand how energy moves, and to recognize that the invisible is as vital and real as the tangible world we experience. The universe is filled with forces that are invisible yet profoundly influential, shaping the world in ways that cannot be directly observed. Maxwell had the extraordinary ability to perceive these forces, understanding that their effects ripple through space, connecting distant objects and phenomena. He recognized that electricity and magnetism are not confined to localized occurrences, but flow through space in a dynamic, interconnected network. This network carries energy, transmits waves, and orchestrates the behavior of light, matter, and energy throughout the cosmos, revealing an underlying order in what once seemed chaotic. Through careful observation and mathematical insight, he showed that these invisible forces can be described precisely. Electric fields give rise to magnetic fields, and changing magnetic fields in turn produce electric currents. This continuous interplay generates waves that move through space, transferring energy across vast distances. Light, as it turns out, is one such wave, a manifestation of these interwoven forces, traveling at remarkable speed through the seemingly empty void. In this way, Maxwell revealed that the natural world is governed not by chance, but by principles that can be understood, predicted, and harnessed. This understanding reshaped the way humanity perceives the universe. No longer are forces acting independently or arbitrarily. They are part of a coherent system in which energy and matter interact according to consistent rules. The flicker of a spark, the pull of a magnet, and the journey of light across the cosmos are all expressions of this invisible framework. By recognizing this unity, Maxwell provided a lens through which the hidden structure of reality could be seen, measured, and appreciated. The universe, though filled with invisible currents, is orderly, interconnected, and comprehensible. Maxwell's insight also illuminated the dynamic nature of the forces that shape reality. These forces are not static, they oscillate, propagate, and interact. Waves generated by electric and magnetic fields are self-sustaining, carrying energy from one point to another without the need for a physical medium. This revelation was revolutionary, showing that energy and information can move invisibly across space. It laid the foundation for technologies that exploit these principles, enabling communication, energy transmission, and exploration in ways previously unimaginable. Radio waves, television signals, microwaves, and even modern wireless networks all rely on the invisible dynamics Maxwell uncovered. Moreover, his work demonstrated the universality of these forces. The same laws that govern electricity and magnetism in a laboratory also apply to light traveling from distant stars, to the behavior of electromagnetic radiation across galaxies, and to phenomena that span the universe. This universality highlights a cosmos connected through invisible threads, where every particle, wave, and field is part of an integrated system. Maxwell's vision revealed that even phenomena separated by vast distances are governed by the same principles, and that understanding these connections provides insight into the broader workings of nature. Maxwell's achievement also underscored the importance of imagination in science. Observing the visible alone is not sufficient to grasp the full complexity of reality. To understand invisible forces, one must conceptualize fields, waves, and interactions beyond direct perception. Maxwell's genius was in his ability to visualize these hidden patterns, to trust in the unseen, and to express them through precise mathematics. By doing so, he transformed abstract ideas into a tangible framework, allowing humanity to study, predict, and eventually harness these forces for practical use. Ultimately, his work teaches that the invisible is not intangible or unreal, it is the foundation of the observable universe. Forces acting through space-shape motion, energy, light, and matter, orchestrating events on every scale. Maxwell revealed that understanding the unseen is crucial to comprehending reality itself. Every wave, every current, every photon is part of this interconnected system, demonstrating that the hidden forces of nature are as real, as powerful, and as essential as anything we can touch, see, or measure. Through his vision, humanity gained the ability to perceive, describe, and harness the invisible, opening the door to a deeper understanding of the universe and its intricate, hidden design. The universe is alive with unseen forces, moving silently yet shaping everything in existence. Maxwell understood that the world is far more than what the eye perceives, that beneath the surface of visible events lies a network of invisible interactions, connecting all matter and energy. He recognized that these forces are not random or isolated, they operate according to precise principles, orchestrating phenomena from the smallest electrical spark to the farthest light of the stars. His insight revealed that the fabric of reality is threaded with patterns, waves, and currents that humans can perceive only indirectly, yet influence everything we experience. Through observation, calculation, and imaginative reasoning, he showed that invisible forces govern the flow of energy, the movement of particles, and the propagation of light. Electric and magnetic fields interact continuously, generating waves that travel through space. These waves are self-sustaining, carrying energy across distances without requiring any tangible medium. Light itself is one of these waves, a visible manifestation of the invisible processes that connect the cosmos. By understanding this, Maxwell demonstrated that seemingly separate phenomena are in fact interconnected, bound together by laws that are consistent, predictable, and universal. This insight transformed the way humans perceive the natural world. Forces that once seemed mysterious, acting at a distance with no apparent cause, could now be described mathematically and understood conceptually. The pull of a magnet, the spark of electricity, and the radiance of sunlight were no longer isolated curiosities, they were part of a grand system, a network of invisible interactions shaping matter, energy, and light alike. Maxwell's work allowed humanity to see order in what once appeared chaotic, revealing that every motion and every interaction is part of a coherent and predictable framework. The dynamic nature of these forces was another revolutionary discovery. Energy moves through fields that oscillate, generate one another, and propagate as waves through space. This process is continuous and self-reinforcing, demonstrating that the invisible forces are active participants in the unfolding of reality. Maxwell's insight showed that energy and information can travel across vast distances without direct contact, and that the universe itself is a medium through which these waves and forces constantly move. This understanding laid the foundation for technologies that transmit energy and information invisibly, from radio and television to wireless networks and satellite communication. Maxwell also revealed the universality of these principles. The same forces acting in a laboratory apply to the vast reaches of space. Light from distant galaxies, cosmic electromagnetic radiation, and even the subtle magnetic fields of planets obey the same rules. By understanding these invisible patterns, humans could comprehend phenomena across scales, linking the behavior of particles to the structure of the cosmos. This universality emphasizes the interconnectedness of reality, showing that all matter and energy are influenced by forces that transcend immediate perception. Beyond practical application, Maxwell's work highlights the role of imagination in science. To understand invisible forces, one must visualize the unseen, conceptualize the flow of energy, and trust in the patterns that govern it. Maxwell's genius lay in his ability to create mental models of fields and waves, to describe them mathematically, and to predict their behavior long before some could be observed directly. By doing so, he bridged the gap between abstract theory and tangible reality, transforming the invisible from a realm of mystery into a field of comprehension and exploration. Ultimately, Maxwell showed that the unseen is as real and influential as the visible world. Invisible forces govern motion, energy, light, and matter, orchestrating the universe on every scale. By perceiving, understanding, and describing these forces, humanity gained the ability to harness them, to extend its reach, and to explore both the immediate and distant cosmos. Maxwell's insight revealed a universe that is dynamic, interconnected, and governed by elegant laws, one in which the invisible is not merely a hidden aspect of reality, but a fundamental component of existence itself.